This is Unit 2, Video 2. In this video we'll talk about the different classes of matter. Classes, from the word classification, we're going to actually categorize, put them in different categories. We'll talk about what matter can be classified into. So first let's talk about mixtures. A mixture, you should be aware of this term, is a blend of two or more different kinds of matter, each of which has its own identity and properties. So here, for example, in this first box, you have just one type of matter, symbolized by just black spheres. And then here you have two types of matter, and so this would be a mixture. On the right side, again, you have just the red spheres, but then the mixture would have two different types of matter, symbolized by black and red spheres. And they are mixed together, and that's why we call this a mixture. So A and C are not mixtures, but B would be a mixture. Now the mixtures could be homogeneous. This word homogeneous, or homogeneous, sometimes referred to, has the prefix homo, which in this case means same. And these are also called solutions. A homogeneous mixture is uniform. Uniform means another word for the same, in composition with the same proportion of components throughout. So for example, if you have that box, say if you have a box of that contains a homogeneous mixture, again with red and black particles, same composition throughout would mean if you take a look, say, at the left side of the box and at the right side of the box, you should see the same amount of black and red spheres. That's kind of the idea. It's the same throughout. No matter, even if you check just one little corner of that mixture, you'll see that it's the same composition as any other corner of the mixture. And you usually can't see the different parts in a homogeneous mixture. It just looks like it's one thing. It looks like you only have one substance. That's because the particles are really well mixed. So an example here, a checkerboard that's perfectly alternating between red and blue would be homogeneous. Homogeneous, again, perfectly mixed, looks like it's the same thing. Now some examples of this is air. Air is actually composed of four different gases. There's oxygen, there's nitrogen, there is carbon dioxide, and there's some argon in there. There's also some water vapor, but if it's dry air. But all four of these gases are mixed so perfectly that air is a homogeneous mixture. The second example here is sugar water. If you make a solution, just a glass of water, and pour some sugar into it, and then you mix the sugar up to where the sugar is perfectly mixed and dissolved and dispersed, you got yourself a homogeneous mixture. But again, you have two substances. You have the water in there, you also have the sugar. You have two different substances, but they're perfectly mixed. A third example that's a little tough to understand is something called an alloy. Steel is an example of it. An alloy, as you'll see on the next slide, is a mixture of two or more metals. So an alloy usually has more than one metal in it. If it just was one metal, say iron, that would just be, as you'll see, an element. But if you have an alloy, by definition, you have more than one element, more than one metal in there. And that makes a homogeneous mixture. So here is the definition of an alloy. An alloy is a metal made from mixing different elements, and they're usually metallic, but steel actually has a non-metallic element, has the element carbon in it, in various proportions. So you can actually make 5% one element and 95% another. You can do a 10-90, you can do a 20-80, you can do any percentage you want. So all the metal that we usually deal with is actually an alloy. So here is a key. This is a brass key. Brass is another example of an alloy. Brass actually mixes the element zinc and copper together in different proportions. If you want it to look more silverish, you put more zinc into it. If you want to make it look a little more orange, you put more copper into it. And this ring, usually rings are not made, even though the ring may be made of silver or of gold, it's really rare for it to be made of pure silver or pure gold. Usually it's an alloy. Usually they add some other elements in there, platinum, palladium, and it's an alloy. Coins are always alloys. It's rare that you'll get a coin of just pure copper or a coin of pure nickel. Usually they'll actually alloy them together. And some fancy coins will have, multiple alloys on the coin itself. Whereas a heterogeneous mixture is a mixture that's not uniform throughout. It's not perfectly mixed. and you can usually see the different parts of a mixture. So an example with our checkerboard is, you notice you have more green on the left side here of the checkerboard, you have more yellow on the right side, so it's not perfectly mixed, and that's the whole idea. There's chunks of yellow on the right side, there's chunks of green on the left side. Some examples of this would be concrete. You know, if you take a look at concrete, or just the sidewalk that you're walking on, you can probably see the different parts in concrete. Maybe you'll see some rocks stuck in there, maybe you see some air pockets stuck in there. There's different colors of concrete. Concrete kind of changes colors. So you see that it's not perfectly mixed, so it's a heterogeneous mixture. The prefix hetero actually means different, versus homo means same. Salad dressing would be another obvious heterogeneous mixture, since you have you can see the different parts in salad dressing. You know, if it's ranch dressing or something, you can usually see little, pebbles of something else in there, or little particles of something else, and that would be a heterogeneous mixture. Two examples here. This here would be like a trail mix, a bunch of nuts mixed together. This would be heterogeneous mixture. And then cake batter, if you perfectly mix it, makes it absolutely perfect, you can say that this is a homogeneous mixture. Two visual examples of the same concept. Alright, now let's talk about pure substances. We've actually discussed mixtures which contain more than one chemical. A pure substance contains only one chemical, only one thing. By thing we mean a chemical. And they can't be broken down physically into anything else. So these will include elements and compounds. Again, it'll only be one substance that's in there, and no matter how much you try, for example, an element, you can't break it down any further physically, that is. So there are two classes of pure substances. The first is an element. Now an element is the simplest form of matter, and this is what appears on the periodic table, and we'll show you the periodic table here in a minute. But two examples are carbon and oxygen. Because they exist as pure elements, you can't break carbon down into anything basic. That would be an element. A compound is usually made of two or more elements, but they are chemically bonded. So chemically, you can separate them into elements, but physically you can't. Good examples are CO2 and H2O, probably the two most famous compounds. Carbon dioxide contains the element carbon and the element oxygen, but they are chemically bound. So it's one substance having one property. You can't separate them by usual means. Same thing with water. Water contains two elements, hydrogen and oxygen, but they're chemically bound, so this is a compound. Now, anytime you have a compound, you'll see there's a formula for a compound. Every compound has a specific formula. So two examples of an example of an element would be the element magnesium. Notice it's metallic. An example of a compound would be magnesium oxide. It's a powder, and you can hear the two elements, magnesium and oxygen, in the compound. But both of these are classified as pure substances. Now, each element or compound has characteristic properties, and these properties help to classify and identify the substance. So if these, for example, this one here could be a compound of two different substances, or it can be an element, and each of these will have a different density, for example. Each substance here has its own density, which means it's a different substance, and we can actually separate them based on those properties. Let's take a look at the periodic table where all our elements are listed. So, and they're listed by something called atomic number, which is the number at the top. So their elements are listed from 1 all the way to 120. We'll get into the periodic table much more in a separate chapter, but here we want to show you that all the elements are here. So oxygen, for example, that we've seen is element number 8. Carbon is element number 6. Hydrogen is element number 1. So you'll be able to find any element. Famously, iron is element 26 on the periodic table. Gold is element 79. Some of these have strange symbols, so gold is AU, iron is Fe, based on their Latin names. But if you want to make a compound, then you would have to combine two of these elements together, and that's how you would make, for example, CO2. So here it says compounds are made by combining in definite ratios. So a compound has to have a specific ratio. So it's always 2 chlorines for 1 calcium. Whereas a mixture, you don't have specific ratio. You don't have definite ratios. You can make any ratio you want with a mixture. Here is rust. This chemical, Fe2O3, is actually rust, made from iron and oxygen. So every element is listed on the periodic table, and we'll ask you to find them and get used to finding them. Now, the periodic table is actually broken up into groups and families, and then into periods. A group or family is a vertical column, so here in yellow is actually the first group or the first family on the periodic table. And the reason why they're called families is because they have similar chemical properties. So all these actually have a similar chemical property. A period then is a horizontal row, so here in blue is the horizontal row, so period 5 in blue, and each period has repeating properties. So as you go, you'll actually see the properties eventually repeat as you go across the period. Now, the periodic table is broken up into 3 sections usually. The first section is the metals. Now, the metals are on the left side of the periodic table, as you'll see. And metals are defined as conductors of both heat and electricity. They're also malleable and ductile. Now, the word malleable is probably a new word. That means you can shape it. It's able to be shaped, usually into sheets. Usually this is defined as hammered into sheets. And because metals have this property, all metals can actually be hammered into sheets. Ductile means you can make them into wire, hold into wire. So these are 2 fancy words that tell us that metals can actually be deformed, easily deformed. And all of these metals that can happen to. Good. The next section in yellow here would be the nonmetals. Now, nonmetals are brittle, and they're not conductors. They're poor conductors of heat and electricity. The word brittle means it can break up, easily broken into pieces. Whereas with a metal, if you take a piece of metal and you hammer it, you put some pressure on it, the metal actually deforms. But if you have a piece of nonmetal and you hammer it, the piece of nonmetal breaks into little pieces. And that's what brittle means. That's the concept here. They are on the right side of the periodic table. You'll notice that there's less nonmetals than there are metals. And most of the periodic table then is made of metals. The last section then is the smallest, and these are called semimetals. Now, they're called semimetals because they're part metals, part nonmetals, and they have characteristics of both of these. These are called semiconductors. So whereas metals were good conductors, nonmetals were poor conductors, these are in between. So a famous semiconductor is actually the element silicon, element number 14, which is used in computer chips because it's a good semiconductor. Now you'll notice that on the semiconductor, or semimetals, there is actually 1, 2, 3, 4, 5, 6, 7, 8 of these semimetals. And there is a stair-stepped line on the periodic table, and those stairs are actually right here. Any element that's touching the stairs is called a semimetal, except this element right here. This element, if you take a look, element 13, is actually aluminum. And even though aluminum touches the stairs, it is actually a full metal. So aluminum is a metal. It conducts electricity really well. Aluminum is actually used in wiring, and so it's the only element that touches the stairs, but it's still a full metal. Otherwise, you have 8 of these semimetals. Alright, so here is a quick overview of what we talked about. We said matter is split into 2 categories, into mixtures, which contain homogeneous or heterogeneous mixtures, depending how well they're mixed. And then we have pure substances, which are elements and compounds are made from elements. And here it says the dashed lines are the 4 classes of matter. So this is a good overview of what we just discussed. Let's do a quick example problem, and we'll be finished. So here it says classify the following as a homogeneous mixture, heterogeneous mixture, element, or compound. So the first one is magnesium metal. Now we've seen magnesium metal, and it's because it shows up on the periodic table. Magnesium is actually element number 12 on the periodic table. Since it shows up, this will be an element. Iced tea. Now iced tea is brewed from many different substances, so there's more than one chemical in a cup of tea. Usually you have the tea itself, and you have some sugar, maybe some lemon in there, and some water in there. So this is definitely a mixture. But the question is it homogeneous or heterogeneous? Well, if it's perfectly mixed, and if you can't see the different parts, then this would be a homogeneous mixture. We'll assume that the ice has melted, and you can't really see anything. This would be a homogeneous mixture. Sugar is actually just one substance, but it's a chemical compound. So sugar is a compound. Sugar, by the way, is made of three elements: carbon, oxygen, and hydrogen. It's actually called a hydrocarbon. So sugar is a compound. Now brass, we've discussed brass a little bit. Brass is actually a mixture. Brass is a mixture of, we said, zinc and copper. So this would be a homogeneous mixture. Now this one, a lot of people think that brass is a compound because it's made of elements, but it's a mixture of elements. It's not a chemically bonded ratio of elements. It's a mixture of elements. So that would be homogeneous mixture. And breakfast cereal, again, you can see the different parts. So this should be a heterogeneous mixture. Hopefully these make sense. Go ahead and think through these for the problem, practice problem 2, and we'll discuss these more in class.